All right, so we're going to start. Before we talk about the difference of squares, we need to do just a quick warm-up. So I want to go ahead and factor or FOIL all of these polynomials. So remember, when you're FOILing, you're doing your first, then you're doing the outer, then you're doing the inner, and then you're doing the last. So we're going to start by multiplying our first two parts of our parentheses. So for number 1, or for dot 1 technically, we're going to do our x times our x to get x squared. And then we're going to do our outer to get negative 4x. Our inner to get positive 4x, and then our last to get a minus 16. Okay, so now I can go ahead and simplify this. I can combine my like terms. A negative 4 plus a positive 4 is 0. So my final answer would be x squared minus 16. Right. For the second one, we have 5m times 5m. So we're doing our first to get 25m squared. And then we're doing our outer ones. So 5m times negative 1, that's negative 5m. And then our inner, that's a positive 1 times a positive 5 to get a positive 5m. And then our last to get a negative 1. Again, we're going to combine our like terms. A negative 5 plus a positive 5 is 0. So I'm left with 25m squared minus 1. Same idea for the last one. 2a times 2a is 4a squared. The outer is 2a times a negative 3b to get a negative 6ab. The inner is a 3b times a 2a to get a positive 6ab. And then 3b times negative 3b is negative 9b squared. Combine our like terms. Negative 6 plus positive 6 means we're going to get a 0 here, so that's gone. And we have 4a squared minus 9b squared. Right, so what this is right here, after our equal sign, these numbers here are our difference of squares. Okay, so if you're talking about factoring difference of squares, we're looking at examples that look like this. Okay, so there are 3 steps that you need to follow. The first step is to make sure that you have an actual difference of squares. So you need to make sure that your 2 terms are being subtracted and that you can take the square root of both terms, and that includes the variables. And then step 2 is to use the following rule to factor. So if you have a squared minus b squared, what you're going to do is you're going to have a plus b in one and a minus b in the other. Okay, so your difference of squares is always going to have plus and minus and then the same 2 terms. And then you check your work by distributing. So for example 1, we have a squared minus 4. So I can first, I see this is a subtraction, so we're so far so good. And then I can do the square root of a squared and the square root of 4. Remember that when you're doing variables with exponents, your exponent needs to be even if you can take the square root of it. Okay, so this is even, so I can do the square root of this one. And I know that a times a is going to get me a squared, so I'm going to have a times a. And then back here, I've got a 4. The minus sign just reminds us that it is a difference of squares. We're going to have a plus and a minus on the inside of our parentheses. But then we look at the 4, and I'm going to do the square root of 4. And the square root of 4 is 2. So I'm going to put 2's there. Okay? And to make sure that's my correct answer, I'm going to go ahead and factor. I'm going to FOIL, doing a times a, and that's a squared. A times negative 2 is negative 2a, positive 2a, and then a negative 4. Positive 2 minus 2, that is 0, so this one does in fact work out. All right, so number 2, I'm going to have you try that one. Pause the video, try it, and then press play when you're ready. So for this one, you should have n plus 8 and n minus 8. All right, number 3, so this time it's just flipped, and that's okay. We have our subtraction here, that's great. 81 is a perfect square, and x squared is a perfect square. So I know we're good. So I'm going to go ahead and put my parentheses, and I'm going to go ahead and simplify this. The square root of 81 is 9, so I'm going to put 9 on both of them. And then I have this difference of squares, so one's positive, one's negative. It doesn't really matter which one you put first. I'm just going to keep putting positive, the plus first. It's typically how you see it, but it doesn't matter if you put the subtraction first or the addition first. And then the square root of x squared is x. So I'm putting x on both of them. And again, check your work. 9 times 9 is 81. That's a negative x squared, and then a negative x, or not, negative 9x, positive 9x. Those cancel out, so we're good. Try 4. All right, so 4 you should have had c plus 10 and c minus 10 in your parentheses. All right, so number 5, we're going to look at this. The first step is to make sure that it is a difference of squares by making sure it has a subtraction sign. This does not have a subtraction sign. So, as the directions say, you need to factor each difference of squares, check your work by distributing, and then if a polynomial cannot be factored, you write prime. So since this is plus, we cannot factor this. It is not a difference of squares. We're going to write prime. So, number 6. For this one, we can do the square root here. We got the square root here. We've got a subtraction here, and this cannot be square rooted. So we're going to go ahead and put our parentheses. Right, and the square root of 1 is 1, so I'm going to put 1 on both sides. The square root of 49 is 7. The square root of y squared is y. And then 1 is plus, 1 is minus. All right, so go ahead and try 7. For 7, you should have the square root of 9 is 3, and the square root of b squared is b. And then we have plus, we have minus, and then the square root of 100 is 10. Right, so we're going to go ahead and jump to the back of this. These are all problems you're going to complete on your own in just a moment. I want to show you number 14 because this one does not have just an exponent of 2. Okay, we have an exponent of 4 here. So remember, whenever you're trying to find the square root of exponents, you're dividing that by 2. Since it's a square root, we're going to do divided by 2. So in our parentheses, we have, okay, our subtraction, so I know 1's plus, 1's minus. The square root of 25, I know is 5. And then the square root of 81 is 9. Then we have n to the 4th. So I'm taking 4 divided by 2 to get n squared. Okay, so you might have something like this. You might have like to the 6th power, to the 8th power. You're just going to divide that by 2 to get your square root. So I want to go ahead and move on to some examples with the greatest common factor. So these ones, there's an additional step. You do want to still look to see if it's a subtraction, and you want to make sure that they're perfect squares. However, these aren't perfect squares, but I can get them to be perfect squares. In order to get them to be perfect squares, I need to go ahead and factor out a greatest common factor. So for the first one, I know it's subtraction, so we should be okay. And I have 2n squared and 72. Well, I know that 2 goes into both of these numbers. Okay, 2 is the greatest common factor between 2 and 72. So I'm going to start by putting 2 on the outside, and then I'm going to go ahead and pull the 2 out. So I'm going to go ahead and do 2n squared divided by 2. Well, 2 divided by 2 is 1, so I have n squared now. And then 72 divided by 2 is 36. Okay, so now I'm left with 2 perfect squares. N squared, that's a perfect square. 36, that's a perfect square. So I can go ahead and do my difference of squares now. So I have my 2 on the outside, and then I have my 2 sets of parentheses. N squared, I know that the square root of n squared is n. The subtraction, so I put 1 plus 1 minus, and the square root of 36 is 6. So I'm going to put 6 for both of those. Okay, so for number 22, it's the same idea, so I want you to try that one. Pause the video, try it, and press play when you're ready. So for this one, we have 18 and 50. The greatest common factor that comes out of 18 and 50 is 2. So I'm going to go ahead and put 2, and then factor out the rest. So divide this by 2, divide that by 2. Okay, and now I have a perfect square and a perfect square. There may be cases where you have a greatest common factor that's greater than 2 that you can pull out, and that's good, but please make sure that you are always pulling out the greatest. Like if you pull out 1, you might have to do another round of pulling out a number to make sure that you have the lowest perfect squares that you can possibly have here. For example, number 25, you might find something else that works, but make sure you have the greatest common factor that you can pull out of both. So I have the greatest common factor for number 22, that is 2. So I'm going to go ahead and put 2, and I'm going to go ahead and put my other parentheses. And I know the square root of 9 is 3. The square root of x squared is x. So put 3x, put a plus, put a minus, and the square root of 25 is 5. All right, so I want you to try 23. All right, so for 23, same idea. We got to pull out our common factor, which in this case it's 2. Pull out my 2, and then I'm going to go ahead and divide by 2. So I have 16s squared minus 9u squared. All right, so now I can go ahead and simplify. I know that the Square root of 16 is 4, and the square root of s squared is s. So put 4s for both. Put a plus, put a minus, and then the square root of 9 is 3. The square root of u squared is u. And that's my answer. So for 24, this one's a little different. So I do have 45 and I have 20. And I know neither of those are perfect squares. I do see the subtraction sign, so I think we could probably pull something out of both of these. And then I have q to the third and q. But those aren't perfect squares either. But I do know that those have a greatest common factor. The greatest common factor between 45 and 20 is going to be 5. But then the greatest common factor between q to the third and q is actually q. So I can pull out a q as well. Okay, so now I'm going to go ahead and divide both parts by 5q. So 45 divided by 5, that's going to be 9. And q to the third divided by q, so 3 minus 1 is 2. Okay, and then minus 20 divided by 5, that's 4. Q divided by q is 1, so that's it. So now I can go ahead and find my difference of squares. So the square root of 9 is 3. The square root of q squared is q. Plus minus the square root of 4 is 2. Okay, so the next one I want to do is number 26. So you can see for number 26, there are 2 already perfect squares there. 100 is a perfect square, 36 is a perfect square. While that's all well and good, you need to make sure that you are pulling out the greatest common factor out of those, even if they're both already perfect squares. Okay, because your answer on the inside is not going to be in the most simplified form, and these problems want it to be as simplified as possible. If you don't get it as simplified as possible, it's not going to work out. Okay, so you need to go ahead and figure out what's the most common factor, the greatest common factor between 100 and 36. Well, I know that's 4, so I'm going to go ahead and pull out a 4. And then I have b to the third and b, and I know the b is the greatest common factor between those two. I can go ahead and do my parentheses. 100 divided by 4 is 25. B to the third divided by b is b squared. And then minus 36 divided by 4 is 9. And b divided by b is 1. Okay, so now I can go ahead and do my difference of squares here. So I have the square root of 25 is 5. Square root of b squared is b. So put 5b for both. Put a plus, put a minus. And then the square root of 9 is 3. All right, so you're going to go ahead and try the rest of these on your own. And please check your work when you're done.